name is Derek Mills, and this is my artificial neural network project for my AI class. First, I want to give you a demonstration of what it looks like in the program, and then I'll actually run through the code real quick. Just my thoughts on this project. It was a really fun assignment, just seeing how the code can fix itself without you actually telling it what weights it needs and how to assign everything, and it was a really fun assignment to do. Given that, the math behind it is very challenging, and I was not able to get it completely working. So I'm going to train. I'm going to say training set 1 finished. I'm going to test it. Accuracy is at 9.68%. I'm going to train it again, test it again. It goes up. However, in my code, it does not improve anymore. However, on the side over here, you will see every time I train, the weights are being updated, but it does not reflect in the accuracy of this assignment. So I'm going to change the learning rate real quick. I'm going to train, test, and actually went down at that point. Train again, test, went down, now it's back up. So I was not able to work through that, but through the code, what I do is I do a stream reader till end of stream, which will run through the entirety of the input file. It's going to break off the current line into the commas, giving me a string of 65 inputs, which I will then parse into a new array right here. Then I'll set the last value to be the last one in that new values array. Then I will begin creating the nodes. So for every node in the first set, I'm going to assign the inputs. Then I'm going to do a calculation. The calculation is a simple, it's going to zero out the input sum. It's going to add all the inputs times their weights to that input sum. And it's going to apply that value through the sigmoid function and assign it to an output. Once that has been done for every node, it will go to the second one and outputs, and then it'll do the same thing. It'll grab all the outputs from the first set and assign it into inputs, do a calculation, which will just do the same thing right here. And that's the last part of the forward propagation. After that, it will look for the highest value. I think this is testing. No, this is training. So what this will do is going to find the highest value. Highest value is going to be set to 0. And if there's an output that's higher than 0, it's going to set that to there. Then once it's run through all of them and found the highest value, it's going to normalize the values by dividing by that highest value. And then it's going to start back propagating. So it's going to zero out the feedback errors. And if the output node is not the true value, so I have the node set up so it's going to assign 0, 1, 2, 3, 4, 4 based off of what position it is in the list array or in the list. So if the list is not the one that we're looking for, then it's going to return 0 minus outputs, which will mean that it needs to feedback a negative weight. If it is the right location, it will feed back 1 minus this, and because it was normalized to be 1, this will return a positive value that is less than 1. At that point, it will start doing the backflow function. The backflow function, it will zero out the delta feedback, and then for every float and feedback errors, which we have assigned here, the output's feedback errors are going to have one input, which is going to be the 0 or 1 minus whatever the output was. So it's going to add that to delta feedback, and then it's going to do the derivative of the sigmoid function, which is e to x over 1 plus e to the x to the power of 2. And that's going to assign the delta feedback. So it's going to run through all of that delta feedback. Then it's going to go down to the first set, and it's going to do the same thing. It's going to take the outputs, and it's going to add the feedback errors of each of the first set based on the delta feedback times whatever the input weights for that node was. Then it's going to backflow each one of those sets. And then once all the backpropagation of errors have been calculated, it's actually going to apply those weights with the learning rate. And that's a simple, for every input weights, it's going to do input weights equals whatever the current weight is plus the output that was calculated times the error feedback times the learning rate. Right, and that the test is pretty much everything up to the forward propagation. At that point, it will assign the best value to be the first one, so it's going to assign it to be 0 by default. Then it'll run through, and if any of the other outputs are greater than 0, so if any other value had a calculation output that was higher than the 0, then it will assign that to be whatever the new one is. And then if that value equals the true value, then it forward counts the test passed. Because every time that one of these tests runs, it increases the test count. And then it'll, at the end, it'll just do test pass over test count for the percentage. All right. Thank you for watching. I hope, like I said, I had a lot of fun working on this assignment. Unfortunately, I was not able to get it working quite right, but I understand the math behind it. It'll just need a little more work next time. Bye.